Welcome to the MS Dev Show, episode number 207. This week we talk with Bettina Heim about quantum computing and Q#, fun with browser console messages, and Google patented an idea from an interview, but they probably canceled the product already.
Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. Check it out today at raygun.com.
This week we have Bettina Heim. She's responsible for the Q# compiler and the Q# language design. She's a quantum physicist turned software engineer. That is super cool. Welcome, Bettina.
Hi.
I mentioned before the show, it's really hard for me to spell physicist. So we are at completely different levels. So I am very glad that we got you on here to talk about this. This is such a cool topic.
Yeah, I'm excited to be on your show. Thank you very much.
Yeah, thank you. Okay, so Carl, what do we have for the comment of the week?
This week we got one off of Twitter from Louis Quintanilla, and he said, "Where has this been all my life? Thanks for the recommendation." And this was in response to the wallpaper recommendation that we had during last week's tips. We got that one from Ryan Loudermilk on Twitter. So once again, a shout out to him for that. But yeah, that's one of the things that we did that we mentioned last week is we really just been putting more and more stuff out on Twitter. Mm-hmm. We've kind of semi-automated how we get the news out there. So it looks like a lot of people have been really jumping in and enjoying, the enhanced Twitter presence that we've been having lately. So if you guys like it, let us know if there's anything you want us to change. I know you had a few issues with some of the pictures that got auto-posted by Twitter because I was putting a link back to our website as well. But, this is all something that we're doing for you guys. If you don't like what we're doing, let us know and we can change it.
Yep. We're just tweaking at this point.
And if you want to get mentioned on the show like Lewis, send an email to feedback@msdevshow.com or a comment on Twitter and iTunes. We really like those 5-star reviews.
Absolutely. Let's jump into the news. We have a lot of smaller news stories here. So the first one is I love little Easter eggs hidden in console messages, so I made a website about them.
Yeah, I know for years, if you go to the source of a page, there'd be somebody who would put ASCII art or some messages in there. And that was a lot of really good ways for people to sneak things in there. Even things like, hey, if you see this message, apply here for a job. Mm-hmm. And, I think an evolution of that is as we've gone to using more and more JavaScript for things, people are detecting when your console is open, being able to put either messages, art, or other things in there. And this person has created a website called console.love that kind of just puts in one place all the different websites that do these kinds of things in your console.
Yep. That's such a cool URL. Why did he put the www on there though? You can go to console.love and it redirects, but it seems, it's such a perfect URL. Why did he have to ruin it with the www? I don't understand that.
There is a reason. There's a lot of people who like and don't like www in front of things. But even though I generally don't like it, I do remember there was an issue that we had with certain corporate domains if we didn't have those.
Oh, interesting. So yeah, that's pretty cool. So I recommend clicking on those and then going to your console. It's pretty neat. Company tried to patent my work after a job interview. This one was crazy.
Yeah. A lot of times that when you're doing things, especially if you happen to be an open source or you're a student and you're doing research, you come up with all these really cool ideas that you're kind of sharing out in the open. And this person in particular had a passion for integrating circuitry into pop-up books. So physical, media that you're enhancing in digital ways. And apparently, I believe it was Google had reached out to this guy who at the time was a student at MIT in the PhD program about some of the work he was doing and happened to interview him. And the funny thing is a while later, he had found out that there was patents applied for the very technology he was talking about during his interviews. And not only that, but the people on the patents were the people that interviewed him.
Yeah. How crazy is that?
Yeah. And luckily, this person happened to go to MIT and had a really strong relationship with their professors. And they were able to like pull some strings and be able to say, hey, here's a bunch of prior art on here. This patent at the time wasn't granted. It was still in the application process. So that really helped kill it fast. But it really kind of puts a chilling effect when you want to just share something you're excited about. Mm-hmm. If you're constantly worrying who might steal or take credit from this, that might be, something that really kind of dampens conversations. And then apparently this is some things that I wasn't aware about either, but there's a difference between owning the patent and being like given credit on the patent. So afterwards, when they were going through getting this discredited, Google was like, well, instead of doing that, we'll make you, one of the people who came up with this.
Yeah,
and
one of the inventors.
Yeah. And at face value, I would be like, sweet, that's awesome. But at the end of the day, all of the technical rights would still be Google's properties. So he turned them down, not knowing that. And then afterwards found out like, hey, this is actually kind of a big deal and good thing I did that. That gives me more rights in the future on this.
Yeah. It makes me think too, it's kind of interesting. Like, I just sort of had this logical progression in my mind. Like, like we almost need to start doing NDAs before we do interviews, if you want to be able to talk about what you're working on. And then I started, taking the next logical step on that. What if you're working on something like super top secret and maybe it's a secret project for like 2 years? How do those people go out and interview? They go to the company that they're applying to and it's like, I can't talk about anything I've been working on for the past 2 years. That I suppose interesting challenges. But yeah, this is definitely a cautionary tale. So I recommend going out there and looking at it. If you are on the verge of, if you have some kind of passion that you're going to be making a lot of money on, or you're basically going to be inventing things. This would have essentially shut down what he was working on from that book perspective. So, just be careful out there, everybody. Yeah, go ahead, Bettina.
Yeah, I just thought the person did an awesome job, apparently, during the interview of explaining what they were working on. Because I was just thinking about my work, and it would be hopeless to explain that in an hour or so.
You just walk in, you're not going to understand what I do. Yeah, that actually is a really good point. They obviously have a knack for conveying complex information. Very cool. Let's see what's next here. How QR codes work. I can't claim to know how they work after watching this, Carl, but I thought it was interesting.
Yeah. So there's an animated GIF if you go to the link in the show notes. And what it does is it shows you kind of the regions of a QR code and what they all do. So there's obviously, if you look at there's some squares that are a little bit bigger that you could tell that they're used to just kind of find and orient a QR code. Mm-hmm. But then with the different subregions in there, they kind of look like just random data. And the GIF shows you, it kind of blocks out each one. It shows you here's where the data bytes are. And here's how you can actually read the bytes, because there's a group of 8 blocks and each block is a bit. And it makes a lot of sense. You can actually just look at that and recreate what all the bytes are in order. And then there's also some error correction in there as well to help detect if you've read this properly. And it's really cool. Like if you follow this, you could look at a QR code and figure out what it means without needing a computer. Granted, that would be take a lot of time and kind of be pointless, but it's an interesting exercise considering I'm seeing QR codes more and more. In fact, we had met for dinner last night, Jason, and on the way home, there was a semi truck where the entire back door had a QR code. Like
that seems like a horrible idea.
Like 6 feet by 6 feet. So, yeah, it might not be a great idea, but they're just showing up in more and more places. And there's other companies that have other technologies that are based off of QR. So, like in the United States, you can walk into a Walmart and their pay system works with QR codes. So, understanding how this works is important at some level.
Right. And I always assumed, I mean, I think every developer has sort of looked at a QR code and it's like, okay, well, I see that there's blocks and those obviously represent binary because you can either be black or white. And, we assume that, there's some kind of decoding that you can do, but it actually is pretty simple decoding. Because I think it looks like it was designed so that it's pretty easy if you had to sort of manually implement this. Like I wouldn't recommend that, but obviously it gets re-implemented across different languages and platforms and things like that. It's not, I mean, you could have like a fairly new developer actually build this functionality once you've done the optical portion and figured out, what bit is in each position. So it's pretty simple from that perspective. Okay, so let's see here. Next one is killedbygoogle.com.
Yeah, so this is a website that's exactly what it sounds like. It lists all of the services and when Google killed them. And going through these, like I was amazed at how many that I had forgotten that had existed, especially some of the older ones. Mm-hmm. And to me, this site kind of reminds me, like in the early days, I really kind of jumped out all of Google's products. Mm-hmm. And one of the reasons why I really kind of shy away from as many as I can is precisely because this page exists, because they killed off all the things that I was using. Like, I don't feel like I can trust Google to fully support something, for the lifetime that I would show interest in it.
Yeah.
There's a lot of really good ones on here too. Like, going back a long ways, they acquired a company called Rightly. That one's gone. Grand Central was a voice over IP service that I know I was using at the time. And then there's just like some fun ones that weren't huge, but Goog 411, there was a 800 number you could call.
I remember that,
and ask some questions. That was awesome. I mean, there's a lot of really good technology that, Google keeps killing. And, what makes this important today is I think Google just announced that they're killing off another one of their, I don't know if it was voice or chat services, but LO. That was one that's only a couple years old and they're killing it off. And
I think Hangouts is transitioning.
Yep. And the replacements for these services really don't even, give you all the features that you were looking for. Mm-hmm. And in some instances, when you go back to like Google Reader, when they had so much of a market share at the time when they killed that off,
crazy.
Like that made a void for many months until other people could recreate RSS readers.
Mm-hmm. I think the page is a little bit cruel though, because they do have like phone hardware on here. I mean, you're not going to, support a phone till the end of time. So I sort
also
of
like Google Glass. I mean, that was
it was sort of a prototype.
They sold it, but it was a prototype.
Yeah. And then, I mean, there's some things on here too, where they were just replaced with something else, which I think is sort of okay. And, I mean, I think we should be clear as well. Like, Microsoft obviously kills products, Apple kills products, like this is something companies do. I think Google gets a lot of flack because I think Google Reader is the big one. There were basically things that they had that people really loved that got killed. And, that's just painful for people. So it's an interesting page nonetheless. Let's see here. Microsoft now lets you log into Outlook, Skype, and Xbox Live without a password. How's that work, Carl?
Yeah, so there's been some technology that's kind of been built into Windows and these other services called FIDO2. Mm-hmm. And it allows you to hook in some hardware authentication devices, fingerprint readers, Windows Hello cameras. All of those can be used to authenticate you instead of having you to type in a password. To enable this, if you go to your account, like account.live.com, you can actually, or account.microsoft.com, whatever it is, it'll redirect. But there's a spot in there where you can actually add, in my case, I enable.
Oh.
No, I'm still talking.
Okay. We just, Skype was breaking up. You can keep going.
What was the last thing? Okay. What you can do is you can add your Hello camera. So what I did is for my Outlook account, I added my Hello camera. Now, every time I open up the website, instead of it prompting for a username and password, it looks at my face and uses that instead.
Yes, this is the future we've been waiting for. Okay, very cool. I don't know if you're still talking, Carl, so we're going to move on.
I just finished.
Oh, okay, perfect. So that's pretty cool. And then one other thing I wanted to mention, or one other story I wanted to mention here was the Microsoft Surface Studio 2 was, I guess it's released. And the only thing I wanted to make on here, basically it's a spec bump. And I know the first one was really considered underpowered. It had a mobile processor, didn't have an SSD. The new one has, let me find the specs here. So the new one has like I think it's a similar screen to what I had before, but now it has a 7th gen quad core i7. You can get 16 or 32 gigabytes of RAM. And now you can get 1 terabyte or 2 terabytes of NVMe SSD hard drive. And then for the video card, for the GPU, you can get GTX 1060 as the base, or you can do a 1070 8 gigabyte. I know it's not a 1080, but it is what it is. It's got 4 USB ports, and then it's got 1 Type-C, basically USB-C port. And I think the rest is the same, gigabit Ethernet, full-size SD card slot, all that kind of stuff. So I just wanted to mention that. The Verge really focus, we'll have the link in the show notes, but they really focus on the fact that the gaming capabilities have really gone up. But just across the board, like this is really how people wanted this thing spec to begin with. It's an expensive machine, and now it actually has expensive internals to go with it. So that's great. And then the last news item that I wanted to mention that we're actually not going to dive into, we're going to dive into it on the next episode, is that Edge is now using the Chromium rendering engine, or I shouldn't say now, it's going to be, it was announced. And there's a long article on it. So we'll have that news story come out. But we actually have our next episode scheduled with next week with Josh Holmes. So he's the guy behind it. And we've been waiting to cover this. We've been waiting for this to get announced. And so we'll have a lot more on our next episode. But now I want to get over to the awesome quantum stuff. Quantum it's such a cool term.
Yeah, it occurs everywhere. For watching powers and everything that's out there is now quantum. Yeah,
I want quantum all the things. Like I want to drink from a quantum coffee cup and, quantum headphones. And it just sounds really cool. So it has turned into a bit of a marketing term, but let's talk about the technical side of this. So I guess we should just start with and I know this is like the biggest question ever, but like, what is quantum computing and what is it good for?
Yeah, so this is a story for the next 3 hours.
Buckle up, everybody.
So the question is, right, what is computing? In principle, we just want to solve a problem somehow, and we are using hardware to do it. And right now, the hardware mostly follows the rules of classical physics. But if we had hardware that would follow the rules of quantum physics, then we could do interesting things with it that are quantum specific and not possible with classical hardware. So in that sense, people have been fascinated, or physicists at least have been fascinated for a while about the power of quantum for computation. But it's only recently been become advanced to the degree where we think we could actually make it work under realistic circumstances. So, and what's it good for? Well, that's also a question that would require a long answer in some degree. One thing is certainly that to kind of understand quantum systems, it's very hard to model them. There's a lot of information contained in them. So to do that with classical hardware, you kind of always have to simplify somewhat. But that makes it harder to understand them. But if we had quantum hardware, the simplification would be less necessary. And we could get a far better understanding of how materials work, how to design certain things. And a lot of optimization is inspired by physics. So we're really hoping that this would give a huge boost also in terms of algorithm development for various optimization problems.
One of the problems that I hear frequently is like breaking encryption, and people talk about how using brute force it would take like 1 billion years to break this encryption algorithm, and then quantum computing could do it in seconds. And then I've heard things more recently, and it's like, well, that's not really true. Like quantum computers, like there's going to be like the beginning of quantum computers or quantum computing, and then things will slowly ramp up. Like we didn't have even what you call classical computers, which I find hilarious. Classical computers were, not great in the beginning, and it took a long time for them to get great. So like, is this, how excited should we be about this?
Well, I think it's very exciting. So I can tell you that how I came across it was in my second year of undergrad studies, where I found this really awesome book, Nielsen Chuang. And I was reading it. It was just super cool. I was like, yeah, this is awesome, but I'm never ever going to work in it because it's so unrealistic. And now here I am. So I think there's a lot to be very excited about. What's important to understand is that it's an entire new tool set and a new arsenal of things we can use potentially. Mm-hmm. But it's not a universal solution for everything. And cryptography is kind of the very catchy thing that caught the attention in media, because suddenly it was like, wait, but what? That would seriously impact how we do things today. Now, the good news is, obviously, once we can actually break the cryptography, it shouldn't be that hard to actually have cryptographic algorithms that would protect the information again. You just need to switch which ones you're actually using in that case. And we're obviously more interested in things that are useful in the in the more benign sense to some degree, what we would want to do with it. Yeah.
So I mean, I guess my question too is going to be like, in however many years or whatever, however much time, am I going to see like a headline that says, Microsoft, makes quantum or invents quantum computing, which is a weird headline, but whatever, just go with it. And then the next day, am I going to see a headline saying like all encryption has been broken, like nothing is private anymore, or is it? I mean, is it something that's, I mean, is it something that we don't have to worry about that much, or like, I mean, is that something you can answer or not? I mean, I know that's a really loose question.
Well, it's a technological development like anything else. So there's always a time scale associated with it. Yeah. And the people who will be the first ones to actually use it and, look into what one can do with it, have been in it for a while and are going to be in it for a while. So it's always a funny thing how media catches up. Yeah. So if you look from the outside, it might seem like it was from yesterday to today, but it really wasn't. And the companies who would actually want to use it will be involved much earlier on. But the headline might be there.
That's a good point.
So what is Q#, and how does that help us as developers work with this quantum computing?
So quantum computing works conceptually quite a bit different than algorithms as we know them today. And in that sense, we found that it makes a lot of sense to have a dedicated programming language, because the way you design a programming language impacts majorly how you think about your programs and algorithms, what abstractions you make and how you compose them. And in that sense, the way we think about quantum algorithms today, and by we, I mean mostly physicists and researchers working on quantum algorithm, is very much founded in mathematical concepts where one wanted to prove that it's absolutely possible to do certain things. But then that's hardly how we are going to actually use those algorithms. Once we know it sort of works, it's always the question, well, what works best? It's becoming more of an engineering effort at this point. And the way you want to think about it is slightly differently. So now we're really moving from, college mathematics towards actual development. And I'm very excited with Q#. I think we have made a very good first step towards making it accessible for every developer out there.
Okay. And then is this within like the reach of your average developer? Like, is this something that I could just like go download and I could actually start using this?
Yeah, I should definitely have gotten you to do that before the show.
I should have. That's my bad.
So you definitely can. It's very easy, hopefully, to download and install. And we're also working to provide material that will actually teach you both, on one hand, Q#, but also kind of quantum computing and quantum computing concepts. So it starts with really easy thing that basically says, like, uncomment this line. So even if you don't know how to program in the first place, you can still get started. And the same thing, if you have no idea what a qubit is, it really doesn't matter.
Oh, okay. That's cool.
So, I'm definitely interested in quantum computing, but if there's no quantum hardware out there yet, why are we focusing so much on this Q# development language?
So first, in terms of there being no hardware out there, I think there might be some people who would disagree with that. We have some hardware, obviously.
Well, no hardware accessible to like us mortals.
Yeah. There's also things start to become accessible. It's a long development. There's certainly not hardware that is large and robust enough to be interesting for real large-scale business applications yet. But then it's, if you look at the evolution of computing in general, that started decades ago and how long it actually took to get to that point. And for my part, I certainly want to be able to do something interesting in my lifetime. So I'm not going to start only once it's there because it's going to take me 50 years to actually learn it. I would rather start today so we can hit the ground running, basically. We are expecting to do the same development that computing has done over a couple of decades within a much shorter time frame.
Mm-hmm. That is super cool. Yeah, and we actually have we can sort of look back at history and learn from that too, which I think is pretty neat.
Exactly.
Don't wait for users to report problems. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications, supports all major programming languages and platforms, and integrates with your current development workflow tools too. There's a free 14-day trial, and it takes minutes to implement, so start resolving issues in your application and check it out today at raygun.com.
So what kinds of problems is Q# good for? Obviously I can't imagine I'm just going to take my existing program and recompile it or rewrite it into Q# and be like, yeah, it's so awesome now. So what types of problems are best for it?
Yeah, so there are a couple of building blocks in quantum computing where quantum has some clear advantages that you simply can't do classically. And the one thing is that basically we've all heard some of the weird concepts. You look at it and then the state changes and whatnot. So there are a couple of specific things. But in that sense, it's mostly good for it. Sort of blind computations, or I'll just call them blind computations now. It's probably not the best term, in the sense that much like machine learning, if you have a problem and you don't know too much about the problem structure or how to simplify it, it might be very good to try to attack it using quantum resources because you have such a huge space and so many tools to actually explore all possible ways of representing that problem in the first place, that could basically determine what the best approach is to solve the problem. And once you know that, you can then have a classical algorithm actually solving it or things like that. So I think it's really an interplay between having classical resources and computers, your laptop at home or data centers and whatnot, and having quantum hardware that can sort of add additional value to that. So it's less of a replacement and more adding additional value.
Mm-hmm. I'm seeing a lot of parallels between, I've heard that as a person, whenever you learn another spoken language, it starts to affect the ways that you think because you learn new words and new concepts and things like that. And it sounds like Q# is really similar to that. As a developer, you learn this new language. It gives you new ways to think about things. And I've heard examples, and unfortunately, I don't know what's NDA and what isn't. So I'm just going to speak in generalities. But I've heard of Q# being applied to some optimization problems. And it's we'll do this. And eventually we're going to run this on quantum hardware. But just the fact that they took this alternate approach to it meant instead of taking weeks to process, they were able to run it, essentially brute forcing that power, let's run it across 100 machines and we'll use this quantum language. And it was just a totally different approach that let them optimize the problem. And normally it would have taken decades on standard hardware, not taking a quantum approach. And I thought that was really interesting. And I know that's really hard to wrap your head around, but so I don't know if you want to talk to that at all.
Well, I mean, speaking also generally, that's exactly the point. It's very interesting to get started and familiar with these kind of concepts now because it's a fundamentally different way of thinking about things. And it's very much complementary. And so in that sense, it's a fascinating problem, and it opens a completely new perspective. And we hope with Q# that on one hand, we are familiar enough in terms of it looks like a programming language. There are a lot of things that are very familiar in what we have. And then there's some slight weirdness that you hopefully get over pretty quickly, but will actually guide you towards thinking in quantum terms.
Mm-hmm.
So when I look at like trying to use this today, what does that look like? Is this something where I could write a simple application on my laptop, or do I need like some sort of cloud service to kind of crunch all of this? Because, this does take a little bit more. We're trying to emulate or, try to recreate how to do something quantumly with our classical computers. So, when I look at like, hey, this is something I want to download and just try to figure this out, what do I need to do to get started?
Yeah, so for us, it was very important that you can really get started, download it just on your laptop. Obviously, at some point, if you want to do something larger, it helps to have more computing resources. But to actually learn how things work conceptually, you can do that without relying on any sort of cloud service. So you're completely independent. It's all free to download. And our libraries are mostly open source, so you can actually go on our GitHub page, and we're very happy. You can contribute back. We're very excited about that, and really start kind of using little bits and snippets to just kind of figure out what you can do with it.
Okay, and then if I write an algorithm in Q#, does that mean that one day when the hardware is more accessible to me, then I could run that same code on that quantum hardware?
Yeah, that's explicitly one of our goals, that the code that you write today, you run it today, you might run it on a simulator and possibly only using like 10 or 50 qubits, something like that. But once we have a couple of hundred qubits available actually in hardware, you could simply, run the exact same code then on that back end.
Yeah, and we've mentioned Cubit a couple times. Can you tell us what that is?
Oh, gosh. Yeah, I really shouldn't have done that. So a qubit is basically, we have bits in conventional computing, right? And then we have quantum bits, which we call qubits. It's a mathematical concept. It's just a two-level system that behaves according to the rules of quantum mechanics. Now you don't know more.
Yeah.
I already feel like...
Can you tell us what a qubit is?
Yeah, exactly. So I can give you all this kind of catchy things. Yeah, a qubit is awesome because it can be 0 and 1 simultaneously and whatnot. But what it really is, even bits, it's not that clear, right? You have some kind of transistor or whatnot to actually represent your bit. So it's kind of a gradual thing as well. And a qubit is also a two-level system. And the idea is that opposed to just being able to be 0 and 1, you can imagine it as kind of a sphere and having some sort of like a compass needle pointing somewhere on the surface of that sphere. Okay. And you can sort of turn that sphere and manipulate this compass needle and hopefully do interesting things. Now, the problem is as soon as you have several qubits, kind of this picture of a sphere breaks down. So it's only so good to explain it this way. But you just ask about one qubit, right?
Yeah. Interesting. Okay. This is like trying to, understand like this 11-dimensional hyperspace or something. I'm just like, nope, I'm out.
So what is the hello world of like a quantum program?
So there are a couple of things you could have different hello worlds. So why is hello world so interesting when input and output is particularly interesting, I suppose, or whatnot? So for us, we have on one hand, teleport is pretty popular, which is basically just getting information from one place to another place, which, is kind of sort of a very useful building block. And I think it's also popular because some of the first experiments that were really large scale across, I believe now we've actually teleported information to satellites and back. And by we, I mean, I wasn't involved.
I can take credit then too. We, the human race, have done that.
Yeah, exactly. So teleportation experiments were some of the first really experiments that captured, the media and things like that were demonstrable. Mm-hmm. showing some quantum effects. From an algorithm's perspective, what's most useful? Yeah, teleport is kind of neat, but it's also very simple from a language perspective. And then there are things that are kind of less simple, where you really start to feel the quantumness of it. And teleport there is maybe not the best example.
I'm just like, I searched the internet, and like Stack Overflow came up. This is in C#. How do I teleport to where I want? It's just funny that some of the question there. Unity, this is different now. This is talking about teleporting in 3D. So this is pretty wild stuff. So is there anything today in Azure that I can use that will help me with quantum computing?
I mean, in a sense, it's Azure. It just has a lot more computing resources than most of us do at home. So it's very useful in that sense, and we certainly have some things there to basically support that. But fundamentally, we do ship the simulator backends and things to run on your hardware as well. And then just once you actually run out of space, then we have Azure.
Okay. And I can simulate, so I can use the scale of Azure then to simulate some of the quantum computing constructs. Okay, cool. Yes, so I could throw a couple hundred machines at it. Very cool.
Yeah, definitely. So the problem is just like 1 qubit more kind of doubles the memory that you need at the very least. So there's this exponential scaling. Hence, we want the quantum computing.
So pretty quickly, I'm like, give me all of Azure so that I can.
Yeah, exactly. So I'll just block off Azure for a couple of years and then you're good. But
yeah.
So, if I start using Q#, is this something that I could start creating a quantum algorithm and integrating into my business logic and applications today?
So what kind of makes sense? I mean, business logic is very wide and there are various different businesses. I think, again, it's a matter of building up some expertise and really starting to ramp up on how to work with these things. And I think there's source for optimism that we will actually at some point have benefits and have gains from this new kind of insight of that the world can be described with quantum mechanics, or at least part of it very reliably. So in that sense, and that's just not, if you want to leverage that and if you want to use that, software frameworks are built up over years in general. And you might not want to throw away everything and then spend 10 years rebuilding it at day X when it's like, this is D-Day, we now have 101 qubits. Now we have enough qubits. I don't know. So in that sense, you will probably want, when you even start building software frameworks today, kind of have in the back of your mind, have some people that are like, yeah, here is where then we could potentially in the future benefit from quantum resources. So I think that's an important part today.
Okay. So for the people that are listening to the podcast, I mean, should they be like downloading Q# today and installing it? Like what is your advice to them? I mean, is this something like everybody should be taking a look at to sort of understand it, or like what is your advice?
Well, I mean, my answer to that is obviously, yeah, you absolutely should.
Yeah.
So I think it's very important. And in as a developer, you continuously try to kind of, familiarize yourself with new technologies and kind of have your daily hour of learning, I suppose. And this is definitely a very good thing to spend some learning. And I'd rather hope that after the first hour, you're very much captured by the fascination of it and spend some more than 1 hour with it. But I think you should definitely give it a shot. We're very early. We're still in preview, so we're not yet at a version 1.0. We're working on that. So it's early software. We're aware of that. However, I think it is really something where even just spending 20 or 30 minutes with it will actually, you should be able to walk away with, that's kind of neat. I learned something. And to me, I mean, that's I just like these little bits and snippets and whatnot.
Okay. I just want to be able to take those, have a response for those snooty F# developers. Be like, F#. I use Q#. I look down on F# developers. No, that's a joke. Totally different thing. This is really interesting because I've been out here. There's a couple articles on it. It's funny watching like different articles try to explain what's going on here, but I think it looks like, I mean, I think you just have to install it and actually just jump in.
Yeah.
I think that's probably the best way to do it. Like you said, take your hour of, each day and just take a look at this.
Yeah, and I also should mention we're starting to try and really engage a bit more and have blogs and have things like that to really aggregate a community around it. And we do have kind of an advent calendar since we're in December now for Q#. So you do get, I believe we have some problem in the shape of Christmas trees and things like that so I just encourage you to kind of check out our homepage, check out our blog and see if something funny comes up and download it. And I think a lot of the items are meant for you to actually implement them, have some nice surprise.
That's cool. Is there anything else that we didn't talk about that you wanted to make sure that our listeners heard? You think we covered pretty well, or?
Yeah, I mean, like the pressure of having this one thing that everybody needs to know, right?
No, I don't know. It was really difficult for us to think of questions to ask, on a topic like this. So, like, is there anything that quantum developers like absolutely need to know?
I think it's really it's hard if you're just reading in the media and things like that. It's really hard to get an overview. So I think it's really important to just sort of get started and not be intimidated by it. So with every talk and every kind of thing that I give, I try to be really encouraging, and in the sense that you don't need 10 years of background and you don't need first thing to dust off your math book to kind of get started. That's really not it. And we try to be very active. It's also, I probably should say Q# we're cross-platform. So it's all on .NET Core.
Oh, okay.
So it's not just Windows.
I was wondering about that.
Yes.
Okay, cool.
Yeah, exactly. Because the initial version was released Windows only. Of course, it has a certain priority for us. But pretty quickly, a couple of months after, we have it all on .NET Core. So you should be able to start. You do need somewhat the oldest Windows version will probably cause you some problems. But aside from that, and anything that comes up, we have our feedback channels, and we try to stay on top of them.
Super cool. And then, so you speak very often on the topic?
I've got a more like a scientific background somewhat, so I'm still trying, even though I'm very, very lazy in publishing because I really hate writing stuff.
I know you do like public presentations occasionally, right?
Yeah. So I try to at least stay in the scientific community in conferences and giving talks and things like that. So in that
that's an interesting approach. Okay, so you come at it from that side and help them understand like what tools we have. Okay, that's pretty cool. I'd like to see that. That's really neat.
Yeah.
Very cool. Okay, Carl, what do you have for the dev tip of the week?
So the first one I ran across because I was doing some async programming, and Visual Studio is really good about telling you if you have an async method, you need to await it. And if you don't do it, it just throws that little green squiggly and puts a little warning in the errors section. But there are times where you might want to do a fire and forget, where you just want to kick off this async method, let it go and run, and you don't care about returning a value or catching any errors or anything like that. And I was sitting there looking like, how do we solve this problem the right way? And I came across this feature of C#7 called discards. And what this is it's a keyword. It's the underscore. So if you have something that you don't care about, you can assign a discard to it. Other good examples of usages for discards is if you have like a try parse method where you have an out variable and you only want to know, did it parse or not? You don't care about what it parsed to. You only care about that. You could assign this discard. And what's great about these discards is when you use them in that case, you're optimizing memory. So instead of actually, if you were to set up a variable and have that assigned and collect that data that's being returned, that's going to assign memory. And now you can lower the memory footprint of your application by using these discard features. There's a bunch of other reasons to use this too, especially around tuples. But I'll let you go check out the documentation for that, because it actually goes through quite a few different use cases. But for me, it got rid of the squiggly on the async. I just do discard character equals my async method, and it worked like a charm.
That's super cool.
The next one is an article from .NETcurry.com. Are you using the right collection in .NET? Are you aware of what the others are? And this was a really great, thorough article. It kind of went through at an API level what a collection is, all the different interfaces that you kind of build onto collections, what methods you get from those. Like you get the count and count property and methods when something uses the iCollection interface. Because I know a lot of times, like I'll get stuck using like lists, dictionaries, and maybe another kind of collection, and I forget about the other ones that are out there, like sets. Mm-hmm. And thinking about the different properties, whether the collection is thread safe or not, whether it's concurrent or immutable, stuff like that. There's tons of them. This article like does a really good job explaining why you would want to use which one, which scenarios they're better for, what capabilities they have, and even what namespaces they kind of came from. It gives a little bit of the history, because we had collections before we had generic objects.
I remember.
And once you start using generic collections, that's an entire different namespace, an entire different reason for wanting to use them. Mm-hmm. So really great article. Just wanted to point that out for those who I think could really just use a brush up on some of the different types that are available in .NET.
Mm-hmm. Excellent.
And finally, I just added a last-minute dev tip. We mentioned earlier that Edge is going to be using the Chromium engine. Mm-hmm. As a response, there's an insider program for Microsoft Edge now. So if you want to get the earliest updates on what that is, go to the show notes. There's a link. You can sign up to be part of this Microsoft Edge insider program.
Okay, if you want to live on the edge, that's the link to use. Dad joke. Okay, and we have a game that we play on here, Bettina. So... would you rather get your snack stuck in the vending machine, or have the ice cream shop sell out the last scoop of ice cream to the person before you in line? I read that really horribly. Yeah, you have to pick one.
I suppose it's the ice cream.
Yeah.
I don't know. It's just winter and I really don't fancy ice cream right now.
Yeah, this is an interesting question. Carl found this one online, and I just had something similar happen to me, Carl. I was in line at a robotics tournament, and I was like, at the front of the line, and they were supposed to have enough pizza for the whole room, you could purchase it, and they ran out right in front of me, and I was really disappointed. So this just caused some flashbacks for me, Carl. So I don't want any of these. I don't want anybody to live through any of these scenarios. Okay. So, anyway, yeah, we'll have a link to, all the stuff that you mentioned in the show notes, Bettina. And, where can people find you? What's a simple place people could find you?
Yeah, so I'm on LinkedIn, and I consciously, I don't have Twitter, unfortunately. I don't have a whole lot of social media, but you can find me on LinkedIn and ping me there.
Very cool. Okay, and then Carl, where can people find you?
You can find me on Twitter at Carl Schweitzer.
And you can find me on Twitter at twitter.com/whytechie. So Bettina, thank you so much for coming on here and talking about quantum computing. It's one of the topics we've wanted to cover for a while, and this was really great information. Thank you so much.
It's been a pleasure. Thank you.